Okay, so you're supposed to determine f prime of x from the first principle. As I said, one of the functions that you will have to know how to differentiate is what we call a hyperbolic function. Now, from rules chain, you already know how this thing is going to play out. In fact, you can use some rules to know the answer, so that when you are working towards knowing, okay, the answer is supposed to be something like this. Remember, the way that Muhammad did this one, she said it's going to be f prime of f of. It's supposed to be f of x first. If you write this thing here, it's going to say you're going to have minus 12x to the power minus 1. Okay? And then from rules, you're going to have f prime of x, which is going to be plus 12. It's going to be 12x to the power minus 2. That's your answer. Okay? And then you can always write it in the positive exponent, which is going to be 12 all over x squared. So that's our final answer. Now, what happens if Elena does this and then they don't do the first principle? You get 0. We want you to differentiate from the first principle. So let's go to the first principle. First principle, we go to our formula first, copying the formula correct. So we take the following formula. It says we have f prime of x, which is going to be given as the limit as h approaches 0. And then you have f of x plus h minus f of x all over what? All over h. What did we agree on yesterday? Wait, we said we are going to start by looking for f of x plus h again, which is part of the formula. So we'll highlight the part that we are looking for. Look for this part first. If you look for that part, what is it that you are going to have then? You are going to get something like this. Let's use, yeah. So you are going to have f of x plus h, which is going to be given as, you are going to have minus 12 all over x plus h. Again, where I see x, I come and put one x plus h. Yeah, that's what I'm going to do first. And then you should ask yourself, which is there anything that can still be done? Do you feel which we can still do something else? No. So we're done here. So what is the next thing that we're going to look for? We are going to look for f of x plus h minus f of x, this whole part here. So I'm going to write that. I made a mistake here. It's f of x plus h here. This is f of x plus h. Next, this is our number 1. Number 2, I'm going to look for f of x plus h minus f of x. That's the next thing that I'm going to look for. And you can see, this is f of x, this is f of x. They're equal. Now, the next thing that I'm going to look for is f of x plus h minus f of x, which is going to be minus 12, okay? All over x plus h minus, open bracket, remember, minus then open bracket, which is going to be minus 12 all over 1 all over x. I will still find it. Okay. The next thing that we are going to do from here then is to say we have minus 12 all over x plus h. Negative and a positive is going to give us what? It's plus. Huh? And then we're going to have 12 all over 1 all over x. Now, if we are going to be adding fractions, because you will remember last year we spoke about the Boy-Tie method. To say we are going to say this one goes with this one, okay? And then we are going to say, because there are 2 terms, this one goes with this one, okay? And then the last thing that we're going to do is to multiply the numerator. So what are we going to have here basically? We're going to have this one multiplied by this one, which is getting the LCD. So what is going to be LCD in this case is whatever appears on the denominator. So what appears on the denominator of this thing here? It's x open bracket, which is this x, okay? And then it's going to be x plus h. All over. If you say this one multiplied by this one is going to give us minus 12x, okay? I will say fine. Yes. If I say this one multiplied by this one, I need to say 12 multiplied by x, which is going to give me plus 12x. If I say this one multiplied by this one is going to give me plus 12h. Secret? Yes. This one, it needs you to know how to add fractions. So you need the skill of adding fractions. So let me just do this so that everyone is visible. Okay. So here you had x, Andish. Now, how do you proceed from here then? Look at this here. Are there any like terms on the numerator? What are the like terms on the numerator? Is minus 12 and 1 and 12. So what are you going to be left with here? You're going to be left with 12h all over x, open bracket, x plus h. What is this? This is f of x plus h minus f of x. So remember, Jane, you're going to get a mark for getting f of x plus h. You're going to get a mark for getting f of x plus h minus f of x. Now we can go back to our formula now and tell them, okay, but now, remember, what does our formula say? It says we have the limit as h approaches 0. So it says we have f prime of x, which is going to be given as the limit as h approaches 0. And then you have f of x plus h minus f of x all over what? All over h. But I know this part here. This part I just got it now. This is this. Do you agree? I think that's what we're getting. We started by getting f of x plus h, and then we got f of x plus h minus f of x. So that we just come and plug it here. Now, look at this here. Because I'm dealing with the fraction, and then you will remember when you're busy with trigonometry, I would say to learners, it's not nice if you have division. You can use the lower case division sign. So yeah, I'm going to write this as the limit as h approaches 0. Now I have this part here, which is a fraction, which is going to be 12h all over x plus h, like this. Now instead of saying divide by h, which is this h here, I am going to use this division line. I don't want it to say divide. You get it, okay? So instead of it saying divide, I am going to use this division line, which, yeah, basically what I was supposed to have here, precedent is this. I was supposed to have divide by 8, but it's a little bit untied. So it's divide. So we can subtract, we can replace this division line with this one. So instead, then now we are going to have something that looks like this. Divided by h. Yeah. But I don't like the division line. Division line lays snacks. I want to change the division line into a multiplication. Now, what happens when you change the multiplication into a division into a multiplication? This is all over 1 again. Whatever was on the denominator goes to the numerator. Let me not skip the step. Let's go there. Now, I am going to have something that looks like this then. The lim as h approaches 0. 12h all over x, open bracket, x plus h, multiply 1 all over h. Okay. Now look at these then. OH, the other h is on the numerator. The other h is on the what? On the denominator. This h and this h, they are going to divide each other out. Né? And then when they divide each other out, we are going to be left with something that looks like this then. We are going to be left with something that looks like this. Which we are going to be left with, can I write it? Yes, you will see. So we're going to be left with lim as h approaches 0, which is going to be 12 all over x, open bracket, x plus h, like this. Now, what I said, the goal was to make sure we remove this one, this h here, which we just did here. So we've removed the h there. So as soon as we remove the h, then we can say h can approach 0. Meaning now we're going to be left with 12 all over x, open bracket, x plus 0, which is then in turn going to give us 12 all over x squared. Now, this is how you differentiate from first principle a hyperbolic function.